A programming language is designed to help process certain kinds of data consisting of numbers, characters, and strings, and to output useful data known as information. The task of processing of data is accomplished by executing a sequence of precise instructions known as programs. These instructions are formed using certain symbols and words according to some rigid rules known as syntax rules. Every program instruction must conform precisely to the syntax rules of the language. Every command in a programming language is known as a keyword. All keywords have a fixed meaning, and these meanings cannot be changed. Keywords serve as basic building blocks for program statements. Every word in a program statement is an identifier or a keyword. Identifier refers to the names of variables, functions, or arrays. Constants refer to fixed values that do not change during the execution of the program. Constants could be numeric constants, character constants. Numeric constants could be categorized as real constants and integer constants. Integer constants refers to a sequence of digits. Valid integer constants are 123, +321, etc. A plus or a minus sign can precede the number. Embedded spaces, commas, and non-digit characters are not permitted between digits. Invalid integer constants are 12_32 and 20,000. Real constants are quantities that contain fractional parts. Valid real constants are -0.75 and 0.0083. Character constants could be single character constant or string constant. A single character constant contains a single character enclosed within a pair of single quotes. For example, 5 or x. A character constant can represent integer values. Arithmetic operations are hence possible on character constants. A string constant is a sequence of characters enclosed in double quotes. The characters may be letters, numbers, or special characters. For example, hello. All data that is handled by the program needs to be stored in memory for later use. Memory is a set of locations in which one piece of data can be stored. Every location has a unique address associated with it. All data that is stored in memory occupies one or more locations depending on the size and type of data. It is very difficult to retrieve the data when required by keeping track of address. Instead, we use names to identify the data. A bit of data used in a program could have a fixed value throughout the course of a program. Constants and variables help us in maintaining fixed as well as variable data. A variable is a data name that may be used to store a data value. Unlike constants that remain unchanged during the execution of the program, a variable may take different values during execution. A variable name can be chosen by the programmer in a meaningful way so as to reflect its function or purpose in the program. For example, average, height. Variable names may consist of letters, digits, and underscores. They must begin with a letter. Some systems permit an underscore as the first character. The length of the variable name should be a maximum of 8 characters, because that is the standard size that is recognized by the compiler. The variable name should not be a keyword. White space is not allowed. Valid names can be like John, someone. Invalid names can be like %123 or 123. The storage representation and machine instructions to handle data differ from machine to machine. The variety of data types available allows the programmer to select the type appropriate to the needs of the application as well as the machine. Every programming language generally has two main types of data type: primary or fundamental, user-defined data type. Primary data types are used to handle generic data like numbers, characters, and fractions, etc. For example, 5x 13.45. The user-defined data types are specific to the needs of the programmer or application. Record of an employee, details of a product. After designing the suitable variable names, we must declare them to the compiler. Declaration does two things. Tells the compiler what the variable name is. It also specifies what type of data the variable will hold. Generally, the declaration of variable must be done before they are used in the program. A variable can store a value of any data type. The name of the variable has nothing to do with it. It is a convention that the names must be relevant. Examples. All these examples are specific to the C language. The general syntax for declaring a variable in C is as follows. Data type v1, v2, v3, etc. semicolon. v1, v2 are the names of the variables. Variables are separated by comma. A declaration statement must end with a semicolon. Valid declarations in C are int number. In C language, int is a primary data type that holds only whole number. Each language uses a different syntax for its declaration statements. In Pascal, the where keyword is used to indicate the start of variable declaration. Pascal uses where char integer semicolon to show that a variable called char is an integer type variable. And it uses where rate real semicolon to show that the variable called rate is of type real. The where keyword does not need to appear next to each variable being declared. It needs to appear once only at the beginning of the declaration statement. In the Pascal example shown here, variables char and rate are declared at the beginning of the program. QBasic declares the variable char to be an integer by simply allocating it an integer value. For example, using char is equal to 9. And it declares the variable rate to be real by allocating it a real value using the statement rate is equal to minus 7.32. Variables are created to be used in program statements. If value is declared as a variable of type integer, then the statement value is equal to 5 assigns a 5 to the variable. Value is equal to amount plus inrate into amount. Here the numeric value stored in the variable inrate is multiplied by the value stored in the variable amount, and the product is added to the value in amount and finally assigned to the variable value. This process is possible only if the variable amount and inrate have already been given value. The variable value is called as the target value. While all the variables are declared for their type, the variables that are used in expressions must be assigned values before they are encountered in the program. Values can be assigned to variables using equal to. Variable name is equal to constant. Yes is equal to y. Year is equal to year plus 1. Old value of year, that is the existing value, is incremented by 1, and that now becomes the new value. Programming languages have a rich set of operators. An operator is a symbol that tells the computer to perform certain mathematical or logical manipulation. Operators are used in programs to manipulate data and variables. They usually form a part of the mathematical or logical expression. Generally, the operators are of three categories: arithmetic, logical, relational. The different arithmetic operators are addition, plus, subtraction, minus, multiplication, asterisk, division, /. Arithmetic operators can be as follows: int a is equal to 5, int b is equal to 10, int c is equal to a plus b. Value of c at the end of addition is 15. C is equal to b minus a. Value of c at the end of subtraction is 5. C is equal to b into a. Value of c at the end of multiplication is 50. C is equal to b by a. Value of c at the end of division is 2. We often compare two quantities and depending on their relation take certain decisions. For example, we may compare the age of two persons or the price of two items. These comparisons are done with the help of relational operators. Different types of relational operators are lesser than, greater than or equal to, greater than or equal to, not equal. Relational operators are used in decision statements. Relational operators always return true or false. 25 is less than 20 returns false or 0. 20 is greater than 10 returns true or 1. Logical operators are used to combine the results of two or more relational expressions. Basically, there are three logical operators: AND operator, OR operator, NOT operator. Logical operators are used like this: A is greater than B and X is equal to 10. Here A is greater than B is one relational expression which returns true or false, depending on the value of A and B. X is equal to 10 is another relational expression, where we are checking whether the value in the variable X is equal to 10. The logical operator AND will combine two expressions into one. An expression of this kind, which combines two or more relational expressions, is called as logical expression. Like simple relational expressions, a logical expression also yields a value 1 or 0. AND operator returns 1 only if both the relational expressions it joins returns 1. OR operator returns 1 even if one of the relational expressions it joins evaluates to 1. NOT operators return 1 if the actual result was 0 and return 0 if the actual result was 1. Each operator has a precedence associated with it. This precedence is used to determine how an expression involving more than one operator is evaluated. There are distinct levels of precedence and an operator may belong to any one of the levels. The operators at the higher level of precedence are evaluated first. The operators of the same level, if existing in one expression, are evaluated right to left or left to right depending on the level of precedence. This is known as the associativity property of an operator. Basically, all the arithmetic operators are executed first, followed by the relational operators, and then lastly the logical operator. That means that the arithmetic operators have the highest precedence, followed by relational operators, and then by logical operators. Among the arithmetic operators, there are two levels of precedence. / are executed first, associativity from left to right. + are executed next, associativity from left to right. Among the relational operators, again, there are two levels of precedence: less than, greater than, less than or equal to, greater than or equal to, associativity left to right, equal to or not equal to, associativity left to right. The logical operator AND is executed first, followed by OR. The assignment operator equal to is executed in the end. Following is an example for the application of operator precedence. The value of X is 10 and Y is 5. X is equal to 10 plus 15 and Y is less than 10. Arithmetic operator plus has got the highest priority among the operators present in the expression. So 10 plus 15 is evaluated first. So the equation reduces to X is equal to 25 and Y is less than 10. Two relational expressions are bound by a logical operator. The relational operator Y is less than 10 yields true. The relational expression X is equal to 25 yields false. The AND of false and true will evaluate to false. So the result of the expression is false. An arithmetic expression is a combination of variables, constants, and operators arranged as per the syntax of the language. Expressions are evaluated using an assignment statement of the form variable is equal to expression. Variable is any valid variable name that adheres to the naming rules specified. When the statement is encountered, the expression is evaluated first and the result replaces the previous value of the variable on the left-hand side. Let us have a look at an example. Result is equal to 1, year is equal to 2. Result is equal to year plus 3. The value in result is now 5 because year plus 3 yields 5. All the variables used in the expression must be assigned values before the evaluation is attempted. No operator is interpreted, so it must be defined. In simple maths, mn is treated as m multiplied by n. But for the compiler, the above is an erroneous expression. Given below are some examples that show how algebraic expressions are to be converted to arithmetic expressions. AB minus C becomes A asterisk B minus C. m plus n into x plus y becomes m plus n asterisk x plus y. AB by C becomes A asterisk B by C.